Okay, we're recording now. Okay, I'm hoping that we've got everybody who's interested tonight, or most people. Welcome back. And I see a few people on here are not strict beginners, and so hopefully we won't put you to sleep. But I do want to kind of go through my take on the initial introduction videos that I mentioned in the discussion group, and just point out a few things and go through, and in particular, if you have questions as we go through, if you have questions when you did it, something didn't make sense, you didn't understand what was going on, or you couldn't get something to work, please bring it up in the group and we'll all learn from it. Okay, I'm going to share my screen here. Assuming I can figure out how to see it myself.
Are you on a Mac or Windows?
I'm on a Mac and I have a second.
So try swiping your hand from off of the touchpad from right to left to switch screens.
Yeah, okay, I'm over here. Do you see my my Fusion 360 screen?
No, we don't.
Oh, that's because I always do this. I forget to hit the share button on the bottom.
There you go.
Okay, there we go. Or double click it. Okay, and what I'm going to do here is start something new. And I'll just quickly go through the user interface. I think most people can probably figure out the user interface from the various videos. We have the workspace selection here. Most of the work we do will be in design. Later, we hope to get into rendering, maybe a bit of animation, manufacture for generating toolpaths, and drawing for capturing drawings where it makes sense, and also for generating output files for the laser cutter. So I think that manufacture will do G-code for the CNC routers and also slice data for the 3D printers. But the laser cutter, we're gonna have to go to a drawing. I typically export a DXF, take that into Lightburn, get rid of any of the borders and things that the drawing package might throw in there, and then go through and do all the Lightburn stuff, connect lines, order them, set up the speed and power, all that kind of good stuff. That's not really available within Fusion 360. But for CNC and 3D printing, it is. That's one element to be aware of. The other element is the data panel. So Fusion 360 stores your projects on its own cloud system. And one of the interesting things it does is it keeps, every time you save, it keeps the old version. And you can go back to an earlier version. You can promote it to the current one, or you can open it. You can have multiple ones open. You can document them, creating milestones, etc. So it keeps a history every time you save the project. So that's kind of a neat one. You can upload files externally. So I've done this, brought in some step files from other CAD systems or other suppliers, etc. There's multiple ways to do that, but that's the key one. So what we're going to do in here, we start a new project, and to have a look at the other elements of the user interface, create, modify, some of the more advanced assemble, construct, inspect, etc. Along the top, we have a browser which kind of provides a structure like a model tree of the project we've got in the open window. Down below, there's some other controls for visual aids, orbiting, for spinning products around. We'll look at it a little bit later, how you display things. And then there's the display cube that allows you to orient your project easily. I think what I'll do then is, does anyone have any questions specifically on the interface as it's laid out? anything doesn't make sense.
I've occasionally had a problem where I wasn't, for instance, working on a component, and therefore the menus look different from when I was in some of the other browser line items. I haven't quite figured out the logic of.
Okay, that's a good one. Let's just hit that one right away because it's kind of key. So I'm going to bring up another project that I've got here in the background. This is one that I've done, and it's got a few interesting features in it. It allows me to sort of animate design. So this is a sensor module, and it mounts onto this plastic mount, which was what I was designing in Fusion 360. And then there's some fasteners and magnets. So if we look over here on the browser, you notice the circle with the dot in it up at the top, which is the top level assembly in this case. So this is targeting or activating a level that we're going to design at. So this is at the top level. If I want to come into my part here, which is this part here, and do some significant things, I'll activate it. And now it's the active part. And menus, and in particular, the timeline will reflect that. If I activate this guy here, this is an imported nut. Here, let me just turn off a device here. This is an imported nut from Mcmaster-Carr using the insert tool here. Insert Mcmaster-Carr component. And so it's only one feature, and we only see that one imported feature for that component. And so if we're working, it's something that catches us often. And I'll be doing something, and it's not working quite right, and I'll realize, oh wait, I need to be, if I'm moving components around or doing something with components, I need to be at the assembly level above that, in this case, the very top assembly. And we can have sub-assemblies within assemblies, but there's this concept of components and assemblies, and then bodies, which kind of gets a little bit confusing as well. But the component focus is important. What level we want to focus on, what level we're doing activity with. Does that help at all, Rob?
Actually, it was me who was asking Travis.
Sorry.
That's the, so I think I heard you say that the menus in the timeline are context sensitive to whatever the body or component or whatever it is I've selected to work on.
Correct.
Okay, good, thank you.
And that context sensitivity gets a little bit confusing. For example, there's something they call the marker menu, which you get with the right mouse button, and it's context sensitive. And in the beginning stages, I kind of stay away from this and from shortcuts, especially for teaching, because I find that I learn better if I go to the menus and I kind of learn the structure in the order that it's put in menus. Then later, I like to use a lot of shortcut keys when I'm working on stuff, but certainly not when I'm teaching because people can't see what you're doing.
Got it, thank you.
No problem. Any other questions about the user interface?
Yeah, I have a question. Are you using the orbit and the pan? Are you using the, you have a Mac, right?
Yes.
I was having a little bit of trouble because I'm following the Udemy training thing, and he's got a mouse with a scroll wheel, and I don't have that. So it's a little bit tricky, but is there a trick to do that, or do you just go down and click it every time and then do it? Or how are you?
For orbit, there's 3 different ways to orbit. So one is to hit the orbit key down here in the little lower toolbar, and then you can come up and grab something and move it around. Okay. And then there's the cube, which allows you to do that as well. And then it's always handy to have this home button so you can go back to home on this.
So you are just using either the button at the bottom or the cube.
Yeah, now if you have a 3-button mouse, if you're doing a lot, I would advise you to invest in a mouse with a scroll button, because there's scrolling in, scrolling out. It's as easy as just rolling the button, and that's so easy because you want to see what's going on over here. I want to come over here and I want to pick this guy right here and then go create a fillet, and it's just too difficult to find it. It's just so easy to be able to zoom in and out like this. And you can kind of do it for panning even, because the zoom in and out goes on where the mouse happens to be. So that works really well. The other thing I like to do is you use Shift and then hold down the middle mouse button, and that does the orbit on the fly. That's something I'm used to in other packages, a different combination, but it works really well. So you can quickly orient and see, what's going on in this little detail here. You just have to hit Shift first, and then the center mouse button, and then you're able to move it around. And when you get all lost and everything's discombobulated, the great thing here is you can just hit this home icon, and it goes back to the default view, which I typically use isometric. Mostly what I've found works the best is the Shift middle mouse button or the cube. I don't really use this orbit tool that often. There are a few other things that you can do down here. The pan kind of comes in handy a little bit. Like I say, I often just use the spin in and out to do an effective pan for me.
Do you know if there's any way to change your mouse operation so that, say, like I'm really used to orbit being a right click easily, and I didn't realize that I was so used to that until I was working with it today and kept like clicking right and not getting that result. But I couldn't figure out if there was a way to change my mouse operations. Do you know?
Usually you can do that with settings on the computer. It depends on the mouse and the mouse software you have. I'm running a Windows mouse on a Mac computer, so I'm pretty much out of luck.
Yeah, me too. Okay, well,
programmability.
I wasn't sure. Thanks. I appreciate the thought.
Yeah. No worries, because this stuff, it all really helps with the frustration level of being able to get to things quickly. It's very relevant stuff.
It's true. Yeah.
All right. What else did I want to show while I was here? Yeah, so you can turn components on and off. There's a component floating in space. Here's a subcomponent of the imported assembly. Oh, another thing I want to point out is I use appearances and colors to distinguish between parts when I'm designing. In real life, everything that you see on the screen is made out of black plastic. But that makes a really boring picture and difficult to look at when you're working on it. So I like to pick colors that are reasonably complementary and sort of pastel-y. It's easier to see. And then also from a display setting point of view, if you look at the visual style, I either like shaded or shaded with visible edges. Visible edges in this case shows me what the fillets are doing and a lot of little detail. If I go to a straight shade, some of that little detail is going to get lost. Okay. Any other questions about the menus, the toolbars?
How did you change the colors? I missed that.
Okay, to change the colors, actually I'll get to how to change that in a little bit. So maybe I'll walk through kind of my take on what was done. Origin over here, you see the little eyeball that you can turn off and on. You saw me doing that with components previously, but here I want to see the origin axes and planes. So what I'm going to do here is show a little bit of my approach, and some of it is different from what you may what was in the video. And part of it is because I'm thinking from a more product point of view and down the road. So usually I like to start out by creating new components that I'm going to use. And so when you do that, a new component comes up and you can give it a name. And I'm just going to call this lesson 1. And the parent is selected. The parent is the top level. And that's important because sometimes I'll create a new component and I have another component in the spotlight, and then it'll make that component a sub-component when I don't really want it to be. And so I have the option to pick what the parent is, in this case, the top level. Activate, which means I'm going to focus on the new component right when it's created. Sheet metal component, we're not going to use those for the time being. This is a specialized type of part. Sheet metal, consistent thickness, you can do various forming, bending operations, etc. But it's not really something I think that we're going to be doing much of. So I'll say okay, and here's my new component over here, lesson 1 in the browser. And you can see it's activated, the spotlight point is on it. Okay, so what we're looking at in the window in the browser is an entire project, not just a part. It might just be one part in the project. It might be an assembly of parts. It might be a complicated assembly with sub-assemblies, all kinds of different things. So most of us probably are going to be doing fairly simple assemblies. We'll get into assemblies later, but for now, let's just focus on a simple part. So the first thing to create something in our part, there's a number of different primitives. So when you hit create and you roll over the menu items, you'll see a pop-up help menu tell you what everything is. And we're not going to go through all of these today. Some of these are more involved. Some of them are simpler. But we're going to start by creating a sketch. Most common initial features and major features are created from sketches. So we'll create a sketch, and we're going to pick a sketching plane. So I'm going to, just to be different from what was done in the video, I'm going to pick this plane, the sort of front-looking plane. And now I'm going to start sketching. And I have my sketch tools over here. And I'm going to sketch a box, a rectangle. And there it is. And I can go in here. You see the dimensions? I can either just arbitrarily let it go like I would with CorelDRAW or something, or I can actually specify, or I can rely on the snaps. So right now, I'm going to go with these dimensions. But if I want these dimensions to be easily edited, I can always add specific dimensions. And I can change them on the fly. And I can do math in here. In fact, I could say I want this to be 2 times 20, and it'll make it 40. Notice these little symbols here. These are constraints. This is saying that I expect this line, it's assuming this line is vertical. It's assuming this line is horizontal. That's what these little symbols up here are on the 4 sides. Now I can add another dimension. I can dimension from here down to, come on, can I grab it? Can I grab it? I can't grab it. It's not, okay, let me try this again. I'm going to grab this dimension first, and then this, or this entity first. Now I'm dimensioning the offset. Now this sketch is not fully constrained. It's not fully dimensioned. The size of the box is fully dimensioned. The size of the rectangle is fully dimensioned. And this offset's dimensioned. This offset isn't. So it's just assumed. It's not locked. And that's okay. We can constrain it fully or not as we choose.
Yep.
When we're done, we're going to hit Finish Sketch, and it's going to put that sketch into our project and take us back to the home orientation.
Hey, Tim,
Yep.
good question. There's one class that I took where the guy has a persistent goal of constraining all dimensions. Is there a reason for wanting to always strive for that?
If you're doing complicated parts and in an engineering environment, you often do want to fully constrain. When I first learned feature-based CAD like this, you had to fully dimension, had to fully constrain. And so some of it is, you know, guys who have been doing it for a long time, and that's kind of how you got used to doing it. It's not a bad practice to fully constrain. And when you're adding constraints, whether they're dimensions or other kinds of constraints, what we try to do is we try to not just randomly add dimensions, but the dimensions should reflect the intent of our design. In this initial sketch, it's not quite as evident what that might mean. But as we add more features, that becomes more apparent.
Okay.
Hey, Tim?
Yep.
I had a question. I noticed in the videos, and then when you did it, when you selected the you selected the plane, when you said you're going to sketch and you said the outside front plane.
Yep.
Your screen automatically shifted so that was flat. Mine doesn't do that. Is that a setting or what's going on with that? Did that make sense to you what I'm talking about?
I understand the question. It should normally always go there. Maybe there is a setting somewhere. So if you
All right.
I'll
look for it.
Yeah, if you look under your name,
yeah,
you'll find preferences, and in here, see what we have here. I don't see exactly where it is, but I'll have a look offline and see if I can find that.
You know, Big Guy, I just wanted to make sure I was seeing your screen and the other videos correct, that they automatically moved there. I always have to adjust it with the Orbit tool.
One thing you could try is go to your preferences and hit Restore Defaults.
Yeah, okay.
You might lose other changes you've made, but...
Okay, thank you.
Hey, Tim, this is Dallas.
Yep.
Two things. First of all, I'll just comment on what Rob just talked about. I had the same experience, and what I found I was doing wrong is I had not activated the component I thought I was working on. So it was actually working in a different plane than what I thought I was in. And the second question I have for you is, in your previous example, you showed where that box, that rectangle, was truly a rectangle, which assumed 90-degree angles. How come? What prevented that from being a something other than a rectangle? How did it know it was 90-degree angles?
That's a really good point. If we go, let's go back in. I'm going to come down here to the timeline. See, here's a timeline. The only thing I've got in my project so far is a sketch. So I'm going to right-click on the sketch. I'm going to say Edit Sketch. So I'm going back into a sketch. Now, if you use the rectangle tool, it's going to assume that you're making a rectangle with horizontal and vertical edges. But if you use the line tool, it's not assuming that. So with the line tool, a few things happen. One is you see a certain level of snap. And when we're going to do another class on detailed sketching, because sketching is really important. But one of the things that Fusion 360 does that's interesting is you can specify your snap by a specific amount, or you can let it do its own intuitive snap grid. So right now, it's snapping basically on a 5 millimeter level. If we zoom way in, it's now going to snap on a 1 millimeter level. And it's really convenient because you can use the snap quite well for doing things like that. Now, if you start drawing a line, so you click once and then move, and as you go towards finding the second point of your line, there's various assumptions it will make as you get close. So if I get close to vertical, it's going to snap to vertical, and you see the little marks there that indicate that it's making an assumption, the little sort of feather marks. And if I go off, then it will do the same. When I get close to horizontal, it jumps to horizontal. So if I wanted to make this a 1/2 degree, I can't really do it. What I end up doing is I go like this first, and then I'll say maybe 35 millimeters, and then I'll hit a tab, and I'll say 179.5. And then I'll get my 1/2 angle. That's kind of the way you need to do these sorts of things.
Well, you referred to that little icon that, go back to your rectangle, you have 4 of what you called feathers. I didn't quite know how to interpret what those were telling me.
Okay, in this case, they're telling you that this line is assumed to be vertical, and this line is assumed to be horizontal.
Okay.
So when you're sketching, and this one here is horizontal, but this one isn't, as you see.
So one thing it tells you is perpendicular, or not perpendicular, but horizontal or vertical. I mean, that's one indication of what the feather means.
Yeah, so the way we talk about constraining a drawing, a sketch. When you constrain a sketch, it's a combination of dimensions and other assumptions. And these constraints here, this constraints menu tells you what kind of constraints are being used and what the symbols are.
Mm-hmm.
So, and there's a pop-up. So horizontal, vertical. Coincident is 2 points that go together. So if, for example, we have this line here, let's say I draw another line here. And I'm going to hit escape to stop sketching it. Now, what I really wanted was this line and this line to be in the same place. I'm going to come to constraints. I'm going to pick coincident. I'm going to grab this point, and I'm going to come down to this point, and it's going to force those two to be coincident.
Right. And yet the feather indicator didn't mean that it was constrained. That was the color of the line, right?
The feather indicator was horizontal, vertical.
Okay.
This line's not horizontal. The reference line is, but the actual line isn't. It's 1/2 degree off because I specified that.
Right. Okay.
So that's the assumption that's being made.
Hey Tim, it seems like constraints remind me of like O snaps. Like you always want to choose your endpoint or your intersection point or your midpoint. But with this program, do you have to tell it that ahead of time every time? You can't just assume, or you can't just tell it in advance, I always want you to grab the intersection, the endpoint, the midpoint. Like you have to tell it in this constraints menu above, like by clicking the triangle, you mean midpoint?
When you're sketching, when you get close to an assumption, it'll make that assumption. Right there, that's the midpoint.
Oh, great. Okay.
Right? That's a midpoint assumption. Here it's assuming I want to snap on there.
Yeah.
But if later I want to change, if I draw a line like this, then I decide, you know what, I wanted that line to be vertical. I can come here and force it to be vertical.
Oh.
So it will assume constraints when you're very close, but sometimes you need to overrule it. Or
Okay.
sometimes you need to put it in after the fact.
Okay, that makes sense. Thank you.
That phrase, assumed constraint, I'm still struggling for how to always read that feather icon, but assumed constraint seems like it's one level less confident than a line turning from blue to black. That would be constrained. The feather
Correct.
is assumed constraint.
So if you look at this rectangle over here, you'll notice a couple of things about it in the sketch. See how the center of the sketch is shaded? That means it's closed. It's a closed profile. Now I can use this to extrude a solid. This one's open. I can't extrude a solid out of this. I can extrude a surface maybe, but not a solid. So that's the first thing. This color here means that the profile is closed. Now you see the top and bottom lines are black and the side lines are blue. Why is that? Well, that's because of a level of constraint that's there. So the black lines, we know that they're 40 millimeters long in the horizontal direction and that they're offset up here. So it's assuming that we know exactly where those black lines are. But the blue lines aren't fully constrained yet. So they're constrained to be vertical, but their position isn't constrained because this area here isn't constrained. If I have my select tool on, I can grab this and just move it, right?
Yep.
Whereas this is constrained, I can't move it. I'm trying to grab this top line and move it up and down, but it can't because I constrained it with these dimensions.
Good, thank you.
If I now come and add a dimension here to, oh crap, that's always a problem. If it seems it's loath to grab the reference planes. If I grab that to here, let me start that again. I screwed that up. One more time. Sketch dimension to here. Now, when I click that, now it goes black. See that? I can change this to, I'm going to change this to, just to be crazy, to 1 inch. And now all the lines are black. It's fully constrained.
Good, thank you.
Yeah. It's not a bad practice to be fully constrained, but you don't always have to be.
So you could extrude without being fully constrained.
You
As long as it
cannot,
was a-
you can extrude without being fully constrained, but you have to be closed.
Right.
Can you be fully constrained and turn off those dimensions?
Hide them?
Yes. There it is. Hide. Nope, just kidding. That's whole.
I don't believe so.
It's hard to read.
The show dimensions in that box to the right.
Yeah, if you turn show dimensions off here,
Ah, great. Thank you.
it'll hide them all. Yeah, but I don't think you can pick one at a time. Okay, I'm going to finish this sketch. And sketching is important, so it's good that we're having questions on it. I think most likely the next class is going to be all about sketching, the next beginner class, because it is really quite important. So here's the sketch we just did. We had this profile here, this rectangle that's closed. We have these guys here. What we want to do in 3D typically is create a 3D object. So most common one is an extrusion. So an extrusion is just take a profile and extrude it like a tube of toothpaste or an aluminum extrusion die if you've been in that industry or what have you, plastic. And you can do that. You can specify the distance by sliding it. You can type it in and have it be that. whoops, I hit an extra enter and basically completed the extrusion. Let me just edit again so that we're looking at it. And there's a couple of key things that we want to note here when we do this. We select a profile to be extruded, and we say where it starts from. The default is the profile plane, and it's generally easiest to understand if we sketch in the plane that we want the extrusion to start from. We don't actually have to. We could sketch in a different plane, or we can borrow entities from a different sketch, but it gets a little complicated and we might confuse ourselves. So it's usually the best to do that. But you can offset. So right now, this extrusion starts right in this plane. If we look from the top, see that extrusion? It starts at this plane. If in fact, we change this start to an offset from the plane, and then we typed in, let's just put a 1 in front of that for that to be 10. Now it starts 10 millimeters from the plane, even though the sketch is here. Okay. It can be one side or two sides. If it's two sides, then we specify the distance on either side. We have 10 in one direction, offset of 10, and then an extrusion 62 millimeters in one direction and 20 millimeters in the other direction. So that could be a little confusing. We have the option to be symmetric. Now, one thing I don't like about it is when you use symmetric in Fusion 360, the number you put in is one side of the symmetric feature. So it's 1/2 of the overall feature. I can do that math fairly easily, but I still don't like it. Another thing we can do is a taper angle. And I think in woodwork, that's not so common. But if we're doing plastics, for example, or anything that goes into a mold, we often use what's called a draft angle so that the part will come out of the mold. So we can taper. Let's do a really extreme one here to show what it looks like. There's our taper angle, and it's tapering from where the sketch goes. Hit OK, close that feature, and there's our feature.
Can you open that again? Sorry, I had a question on it.
Sure.
When you were talking about giving the full distance, if you click next to measurement, the second icon, and then, but that's not the default, so I don't know.
You're right. And
Go Nancy, go Nancy.
Thank you. Thank you. Sometimes we have a habit, and I certainly do, of, going with defaults and quickly bouncing through menus. And as you use it more and more, you learn things. And one of the things that I enjoy about teaching is sometimes I learn different things from different people. And in this case, we're actually learning this program together. I'm trying to stay ahead of everybody, but I am also fairly new to it. I've been using it for about a month now. I'm finding new things every day, and thank you very much for that one. Another thing I didn't point out was the operation. So the operations that you can do, you can create a new body within the part. You can join to an existing body if there is an existing body. You can cut. You can do an intersection. And if you're doing it as a body at the top level, you can create a new component. So you can create a new component from your first extrusion, or you can create a new component and then sketch inside it. I prefer to do the new component and sketch inside it, because then that initial sketch is contained within my component. But that's sort of a hierarchy or organizational thing. If in fact you're mostly doing one part at a time, you're not doing assemblies, it's a lot simpler. A lot of the nuances that I'm talking about aren't as relevant to you. So I don't want to talk about them too much, because we'll cover them a little bit more later. Any more questions on this extrusion creation?
Yeah, I have a quick question. What are you clicking to bring up the edit feature? How are you bringing that up once you've already, like, you hit enter by accident before and then you said, let me just go back?
Right. So down below is the timeline.
Okay.
And you see you can play through it, and what's in the timeline? You have a sketch, and you have
I
this
can't
extrusion.
see it because of Zoom. All right,
Yeah.
that makes sense.
And if you right-click on them, then you get this pop-up menu. Do you see the pop-up menu?
I do that. I see the Zoom bar at the bottom is covering the timeline. So,
Okay, no problem.
but I see where it says edit feature there. Is that what you're clicking on?
Yeah. Then I hit
Okay.
edit feature.
Got it.
Or if I wanted to edit the sketch, I could.
Okay, thank you.
You bet, no problem. Okay, now, once we've got our first feature created, the first extrusion, now we can do some other cool things. So let's create another sketch. Now, we can either select sketch and then the plane we want to sketch on, or we can sketch the plane first and then the sketch icon. Whatever's most convenient for us. And you'll see at this point, this isn't a complete top view because we're now sketching on that angled surface. It's angled because of the taper that we included on the part. So I'm going to go here under sketch. I have a whole bunch of different kinds of things that I can sketch. I'm going to go to the line tool. And I'm going to sketch a line here. Let me zoom in a little bit. A line here. And then I'm going to hold the button and move it. And when I do that, it does an arc, which tangent to the line it was attached to. And then when I finish, it's done with that arc. You see that? It's a bit tricky, but when you're making lines, you do individual clicks for the endpoints of the line. But if you want to do an arc, then start dragging it first, and then you'll see the arc happen. Okay, I'm going to close this right here. Now I have a closed sketch. In this case, I'm not going to bother to dimension it or constrain it. Now you see it's made a couple of assumptions already. It says this line here is parallel to this line. These are the parallel constraints that you see up here as well in the menu. And this menu here, or this icon here, says that this arc is tangent to this line. Does that make sense?
Yeah, but if you wouldn't mind drawing one more real quickly so we can get that sequence of events.
Yeah, okay, that's good point. So I'm going to start with the line, one click, and then move, and it's creating a line. Now I make my click to complete that line, but if I now hold the button and drag, now I'm doing an arc, and when I release the button, it finishes the arc.
Got it.
Now, when I go to make the next line, if my line is if my line is close to being tangent, then it assumes that tangent, and you see the little tangent symbol, the circle and the line above it, right at that intersection. But if I go off to the side far enough, it doesn't make that assumption. Now, one thing, it's one thing to do things that way, but it's also sometimes easier to just make a sketch with lines and then fill it later. Okay, so we can fill it as an arc. Now, I usually fill it my Oh, actually, it might be under modify here. Modify fillet. Now you can come here, create a fillet, and set the radius this way. Okay. I'm going to finish this sketch for now. I've got 2 profiles inside this sketch, but that's okay. That doesn't matter. You can do all kinds of complicated things with sketches. One philosophy I have is I try to keep my features and sketches relatively simple and make more of them, because I find it easier to go back and edit when I'm not trying to do too many things in one sketch. It's easier to constrain, easier to dimension, etc. Okay, so I'm going to try and create a feature with this. And I'm going to try and create a revolved extrusion this time. And I'm going to select this profile. And for an axis, I'm going to try and pick this edge as the axis. Now it's taking that profile that I've selected, and it's going to make a revolved solid out of it. If I go the other way, whoops, if I go backwards, it's making a cut. And you'll notice while I do this, come over here and watch this operation. See how this operation says cut right now? If I grab this and go this way, it's changed to the default being join. And if join isn't what I wanted, I can pick something different. I could say it's a new body or it's a new component of its own. Since I'm highlighted on the lesson 1 part, if I say new component, it'll be sub to that part, which is a bit odd. Part sub to a part. But generally, this is the kind of thing we're doing. Let's create this as a cut. And even though it's, actually, let's do something different here. Let's change is the angle going to go to a surface? No, it's just going to do an angle. Where am I actually cutting? There. Okay, now I've created my feature. Where's my feature? It was right on top, right? This is where I sketched it. But it was a cut, and it was cutting through thin air. Oops, so, I'm going to go back to home because I lost track here. I'm going to use my shift. And there's the feature that I cut because it cut through air up and around and down into there. Kind of weird. I just wanted to show you the revolve feature a little bit.
Yeah, it looks like a pretty useless part, Tim. Sorry.
It is. It's not even that artistic.
But the Revolve is kick back butt. Wait do you see what you can do with it?
Yeah, it is.
Yeah, one of the things I did the other day was because you can render, I was looking at things that we could look at rendering, and I was also trying to do more woodwork because, you know, most of my career I've designed plastic and metal parts, glass, electronics, etc. But since it's woodworking, I wanted to see different stuff I could do with woodworking. So I made a laminated piece with different kinds of wood, and then did a revolve cut as though it was on the lathe to see what it would look like. Just to be different.
That's why Mark spoke up for it. He's a lathe man.
Aha.
That's a great idea, though.
Now, remember how I was showing you how to do those fillets? I rarely do those fillets in a sketch. Usually what I do is I do real simple rectangular kinds of things. And then afterwards, I create the fillet as a modification of the solid. So I'm going to create a fillet here, and I'm going to grab this line, this line, this line, and this line. And I'm going to make, whoa, that's too far. Let's say I want to go with, let's see what 5 looks like. Oh, that's not big enough. How about 25? Oh, that's too big. What's going on here? I selected something I didn't mean to. Oh, I got a face here. Let's unselect the face.
Yeah.
Let's unselect this face. I'm going to remove that selection and start over. So let's grab this guy, this guy, this guy, and this guy. Now I have 4 edges. That makes more sense. Now, let's go with 50. And I just typed in 50 and hit enter, and that finished the feature. Now you see this fillet has filleted out this sharp edge in here. If I do another fillet, I'm going to make sure that tangent chain is selected. And I'm going to grab this edge. Now it grabs all 3 of these edges because they're one tangent chain. And another one. And another one. And another one. And this time I'm going to say 30. Something weird happened. Something went wrong. How did that do that? Huh. Okay, that's an oddball. I have been finding a few glitches, but sometimes there were a couple of computer science people in the group, and you're effectively, what we're doing is programming a part, and sometimes we're not doing quite the math we think we are.
Tim, to do this, you had actually chosen a term I actually find fantastic, a tangent chain. There were 4 tangent chains along the 4 edges there, and then you put a fillet of the same dimension on all 4 simultaneously. Is that correct?
That's correct.
Okay, good, thanks.
Now, I can create multiple groups and have different dimensions within the same fillet feature. I tend to create a lot of independent fillet features because I just find it easier to then go back and edit. So I'm going to leave this one at 10. I have this part like this. And again, I could do another fillet. Grab this tangent edge and this tangent edge, and make a nice small one, and there we go. So yeah, tangent edges, fillets, these are cool, cool features. And we still have our cutout in there.
Okay, let's go 3D print it.
Okay, let's go 3D print it. And full disclosure, I don't have a 3D printer. I haven't used a 3D printer. When I'm designing products at this point, I export a step file and send it to a service bureau, and they send me back a nice stereolithography part.
Cool.
The part that we're looking at here, I did that with this part. I got my prototypes. I did a fit check. I tweaked the dimensions, told them to make me 20 more. Those will go into testing, and meanwhile, the file goes to the mold maker. That'll make an injection molded die, and then we'll make tens of thousands of these parts.
What was that again?
This is a little sensor block for a security device. And this holder with a magnet, it can be placed in remote locations on equipment or on trailers or whatever. Or without the magnet, you can bolt the holder to something, and then
Okay.
various different kinds of sensors can be inside the box.
Cool. Thanks.
Bit Big Brother-ish, so I don't want to get into too much detail. Let's go back to this guy. Okay, so full disclosure, I wasn't planning to get into 3D printing today, but I know that's a big interest of people. And so I'm going to make mistakes doing this, and at least one or two people on the call are going to correct me. So if I'm not mistaken, we should go to manufacture. I might be mistaken. There's G code for milling machines.
Tim, I didn't actually mean to take you in that direction. It just looked so eminently 3D printable that
Yeah.
was a visceral reaction. That's all.
Yeah, I want to do a little more homework before we really go into 3D printing, because
Great.
it isn't something I've done from Fusion 360 yet. I went through it once to see how it worked, and obviously have since forgotten.
One of several people on this call who could probably give you information is Mark. I believe, Mark, you use Fusion for design of 3D printed parts, correct?
Yeah, all the time. I can help out.
Okay.
I'm to be honest, and I don't mean to watching Tim go through this in a different way has actually been very educational, because it's very different than I do it, and I'm actually learning a lot. So, I mean, there's a lot of different ways to do things, and watching someone else's mind work is actually very educational. But if we get to a point where you want to take it offline, Tim, I'll gladly show you how to do that.
Yeah, maybe, my intent was that every other week, so next week, we would have the beginner class early on, and then later have other people join, have more of an overall, maybe a little more advanced topic. And maybe you can take charge and show us how to do a 3D print.
Sure.
That'd be great, a week from now. So we'll get off, we'll touch base offline about that. Just want to look at my notes here and see what else I wanted to show on this side. And I think this is most of it. There's a lot of, we got a little further into sketching than I had intended to, but there's a lot of detail in sketching. And we're going to want to focus a lot on sketching, because there's a couple things that are key from a philosophy point of view of being good at this kind of tool. One is knowing how to visualize the parts in 3D in your mind, kind of as you're working on them. You kind of do some stuff as you go, but you got to have some breakdown before you start. Secondly is being able to figure out what makes sense from a feature point of view, how you structure things feature-wise to build a model that's robust, that can be modified in the future, and that's easy to understand as you go. Like I said, my preference is more simpler features rather than fewer complicated features. And then the other is to capture a design intent. When you constrain, when you dimension, as you build it, think about what's the part supposed to do. When you put in a dimension, why is that dimension relevant? So if you're dimensioning a cutout and you don't just give a distance to the nearest edge, you give a distance to the edge or plane or surface or feature that it makes sense to dimension from based on what your design is intending to do.
And then also, we can do some really phenomenal things like you currently have done, but is that manufacturable with wood using, the tooling that we have? I don't know if that could be, that's a combination of routing and filing and sanding, and I don't know.
Yeah, that's a very good point. And we really run into it in plastics, because it's very easy to design something in plastics that you can't mold.
Right.
And so there's this inspect menu, which includes a number of things. Curvature analysis, draft analysis is, draft angle is the little bit of taper you use so that plastics will come out of a mold. I say plastics, it could be castings as well. Done a lot of castings design as well, just not as much recently. Curvature map shows you what the surfaces look like. And then this accessibility analysis, this is telling you here that there's an undercut, that part's not going to come out of the mold. And I'm not sure what all tools are available on the CNC to see this kind of thing. I'm not sure what it does with, for example, a sharp internal edge. If you have a sharp internal edge in a design and you go to make G-code, what does it do? Does it error out? Does it tell you? And or does it just get the minimum based on the tool you're using? I don't know. I haven't played much with that yet.
Yeah, I mean, there was a prior discussion earlier about vacuum clamping, and there was a great little vacuum hockey puck, if you can call it that, that could be done on the CNC, but in recapping it, I didn't see how the holes could be drilled. I mean, have to be some manual processes done before this thing could even go into the CNC, and how do you determine that? How do you draw that, or do you even draw it if it has to be a manual process? Because the CNC can't do that, at least in my mind. So I don't know if Dallas can weigh in on that, because it was his clamp. So, but I don't want to get off topic here. So
the one thing I will say is you can create all those post-processing features and suppress them to generate the file for your G-code file, and then but show them in your drawing so that you can actually specify in a drawing what processes are happening after the main manufacturing process.
okay.
You can do the same thing. So if you're doing a casting, for example, you could have the casting design, and then you can have the machining design, and you could still also have manual processes design all in the same part, built in, just in a sort of progressive reveal.
Got it.
Is anyone interested in looking at the, I was going to go through an alternate approach to the bookcase as well. But before we do that, does anyone have more questions on the stuff we've done so far?
Tim, I just scrolled up and down the list here. I don't know that we actually have anybody who's a real beginner, but I maybe consider myself more of a beginner here. And so let me ask a kind of dumb question. There are a series of words which we all take for granted when we're talking about these things in Fusion 360. They are sketch, body, component, part, assembly. These words sort of relate to one another, and sometimes they're actually names for pieces in the outline on the left-hand side of the screen. Is there some hierarchy or some definition you can briefly give of how one of those relates to the other, or how they progress, like sketch to body and body to component, and something like that, that just puts them all into a framework that sort of demystifies them?
Yeah, I'll try and explain it. You pretty much hit it. So a sketch is a 2D virtual entity, which is like a construction tool. So it doesn't exist in the 3D space, really. It has no mass. It's not a solid. It's a 2D for the most part. I won't get into 3D sketching for now. It's a 2D sketch is an outline of something, typically a profile that you're going to extrude, or you're going to revolve, or you're going to cut. You're going to do something with that profile or with entities in that sketch. When you extrude or revolve it, now you've created a body. And you can have a body is kind of like a part, but you can you can have multiple bodies in a part that can then be joined together. If you look at the bookcase example that I had linked, he built the bookcase with all different bodies. I tend to do that all as components.
Got it.
Because I view those as components. But some people are comfortable doing that as bodies. You can include those bodies in a component. So a component is typically a part, or if it's something that you never do anything else with, you might have a sub-assembly, what's in reality an assembly of several parts, you might represent as a single component of multiple bodies.
Okay.
Just because you've locked them together. Now you can fix them together in a rigid group as well. That's another way to do it, but sometimes it'll keep it simpler just to do that. An assembly just means more than one component. And so you have the multiple components and you define the relationships between them using joints typically. And a complicated product might have a sub-assembly. So for example, if you look at a car, so there's a sub-assembly called the rear brake assembly. There's a assembly above that, which is a rear wheel assembly. And then there's a drive line assembly, and the drive line's part of the car assembly. So you have multiple levels of assembly in there.
Got it.
To have a hierarchy to organize your design and to make things reusable, because probably you want to use that same wheel assembly on another vehicle, for example.
Thank you.
Welcome.
Before you leave that, there's one other term that is used in Fusion that I'm unfamiliar with. It's when you bring in an STL, it comes in as a mesh. What is it? How does a mesh fit into that hierarchy?
Typically, a mesh refers to an object which is not a truly 3D solid object, but it's a skin. So it's a mesh of surfaces. And when you bring in, STL doesn't define a 3D object typically. This is an odd thing to say, I realize, since its main purpose is 3D printing. But an STL file uses triangles of various sizes and resolution to approximate the external skin of a 3D object. And when you import a surface model like STL, or in some cases STEP can be surface model, IGES is a surface model typically as well. When you import a complicated surface model into a CAD system, sometimes the import software doesn't do a perfect job. So you import that it's a mesh, and you have to make sure that it's closed in order to solidify it. Or sometimes you'll actually intentionally import a surface, and then later you'll thicken the surface into a solid. So a mesh refers to a group of surfaces that are connected together, because typically surfaces are fairly primitive, what we call primitive. So rectangles, triangles, things like that. But you have a whole mesh of these surfaces that define a complex surface.
And that complex surface would be the equivalent of a body?
It would be the skin of a body. Once you make it solid, then it'll be a body.
Okay.
So if you bring it in and the translation is clean, you can solidify it.
Got it.
If you bring in a step file that's been saved as a solid file, generally the step file will come in. So, like if I go back to this part, so this yellow part here, this top, was imported as a step file. So it's solid. It's only one feature because we've lost all the history bringing it in. If we drop the cash, if we drop the $500 a year or $60 a month to buy the professional version, we can import SolidWorks and Pro Engineer files and things like that and get all the history. but generally we don't. And then, so all those parts came in. The magnet, the screw part and the nut part were imported as also as step files from Mcmaster-Carr. And the magnet was imported as an external step file from the magnet manufacturer. And then the plastic part here is the only one that was actually designed in Fusion 360. So it's the only one that has this extended timeline. And in fact, you know, one of the things you can do with the timeline, let me turn some of these other things off. We can actually go back. I think I'm going to lose an orientation feature here, but we can go back to the beginning and see a sketch and a feature. Yeah, I lost an orientation move in there. And we can step through, come on, we can step through this. Well, there it's playing. It's stepping through and showing you the history of how this part was made. It stopped. Let's keep going. Oh, come on. Oh, I see. Let's go to the end. There's all the features. If we hit play, now to go back to the beginning. You see some dashed lines in there. Those are construction lines that are used for various purposes. Some planes popped up. I like using construction planes sometimes. Some features on the other side you don't necessarily see being built, some polygons. And then the last thing is all the fillets going in. And now I have my part.
And this was a real world project of yours?
This is a real world project of mine, yes.
Cool.
So all these side surfaces have tapers on them. None of them are vertical. Sometimes I build the part vertical and add draft. That's kind of the way I was used to doing. There's a draft feature under modify. But in some cases, because extrude has a taper feature, in some cases I'll do it in the initial extrusion. It really depends on what I'm going to need as construction elements later that I borrow from the part.
So a question on components versus bodies. Is there say you have a body or a component, would one show you interference issues before the other, or would they both similarly show you interferences with other bodies or components to steer us one way or the other to define components or just use bodies?
Generally, you would use components to see interference, because when you create multiple bodies inside the same component, if you join them, it will join any areas of overlap. You can do the intersect to do an intersection of the two, and that's something that's not done that often. I'll sometimes do an intersection of parts. So if I have a part that I've worked on and then somebody else works on it,
right,
I might put the two parts together and do an intersection set to see the difference.
Okay. All right. Yeah. Thank you.
I have a question. A question about all these parts that you imported. When you import them, you can't edit them? Is that part of the deal?
You can actually, and this is one thing that is actually kind of amazing and impressive about Fusion 360. This caught me by surprise. There's a lot of, I found a number of areas where it's a lot weaker than the more expensive CAD packages I've used, which is what I would expect. But editing an existing part is kind of interesting. So I'm going to turn this guy off, and I'm going to turn, let's see, what did I want to turn on? I lost my other parts. Let's see here. Can I go back? It does some weird things when you scroll back. Okay, so I'm going to take this. I'm going to turn this screw on and turn everything else off, or this nut. Let's do it with the screw. So if you look at this screw, there's a feature called press pull. It does a number of different things. I'm not sure I figured out everything it does yet, but it does allow you to modify existing geometry that's come in. Now, one of the things I need to do here, before I screw up, I can't activate that. Why not? I can activate this. I think because I've linked that to something. So what I'll do it with a nut instead. So if you notice the nut, there's one feature here. And I can't edit it. But what I can do is I can use press pull. I can grab this face. Come on. Now the face is getting smaller because of the fillet that's on the nut. See that? Let me try something else that'll show it better.
And then you try to order the part and hope that it looks like that?
I just wanted to point out that when you import a model, there are still modifications you can do to it. You're right, this does not make sense at all to do. But it's a capability so that when you do import a model, import somebody else's model, you can mess with it. And there it is.
So say that's a McMaster nut. It comes in with a certain part number. If I modify that, do I get a flag that when I want to assemble this thing, that's really not that part number from Mcmaster-Carr?
No. The Mcmaster-Carr insert, so there's a feature here where you can insert parts derived from other parts. You can put decals on surfaces. You can bring in what's called a canvas. You can bring in a picture and sketch around it. You can insert meshes, SVGs, DXFs, other manufacturer parts for CAD is a whole bunch of manufacturers. Mcmaster-Carr, I think they just made a good deal with AutoCAD. And if you haven't used Mcmaster-Carr, I love them because I figure stuff out and I order it late in the afternoon and I get it the next morning.
Same day.
Yeah, it's amazing. They're really good.
Yes, they are.
But this is strictly an insert tool. So when you say insert a Mcmaster-Carr part, you go to their catalog the same way as their catalog is online. Same thing you're used to. You pick screws and bolts. You can pick a size, a type. Grab the part number. Hit product detail, scroll down, 3D step, save it, or say save, and boom, there it is.
Oh my God, that's amazing.
So it's just a shortcut. In other CAD systems, I would go to the Mcmaster-Carr catalog online, download the part to my computer, the step file, import the step file into CAD, and then move it into my assembly. So they just made that step, no pun intended, really simple. And as a result, it's probably a bonus to both Autodesk and to Mcmaster-Carr. I love it. It's a fantastic
and
feature.
engineers, yeah.
It's a fantastic feature. And I like Mcmaster-Carr's supplier as well. They're really solid. One more thing I really wanted to show people, and then we can come back to this maybe a bit later, but I wanted to show a slightly different approach to the bookshelf. So this is going to be my bookshelf. I'm going to save this, name it bookshelf, if I can type, bookshelf 2, and that's going to save it to my, my workspace. I'll turn origin on for now. I'm going to create the first sideboard, but I'm going to use a feature called a box. So a box is basically an extruded rectangle. Again, it's a shortcut. So I'm going to create this box. I'm going to do it on here. And there's the first corner. There's my second corner. Now I'm going to see, let's see, what did I want this to be? Right, this was done in inches, wasn't it? And I didn't change inches. So I'm going to put in 12.5 inches for that dimension. Then I'm going to hit tab. It's going to take me to the second dimension. And I'm going to put 0.75 inches for that dimension. Oops, I missed one dimension. Oh, that's the height. So the height here, I think it had been 55 inches. And this is going to be this operation. Let's make it a new component. Say OK. And then let's hit the home button. There's that board. Now I'm going to go in here. I'm going to give it a new name. And I'm just going to call it side panel. I noticed in some of the tutorials that people put a description of the material and length in the part name so that it showed up in the cut list. But in the cut list or the parts list, there's also a description page. And I prefer to put it there. And my reasoning is that I might come back and change my design. I do a lot of iterative design. Hey, I make it once, I look at it and go, that's too short and fat, so I want to make it tall and skinny. I'm going to go in and edit it later. And so I'll wait till the last step when I'm making the drawing to actually put that level of detail in for the parts list.
Tim, you said you were going to put it somewhere other than in the name of the body or component. Where did you say you were putting it?
When we get to drawings and you have a parts list,
Got it. Okay.
you have a description.
Got it. When we get to the description and part list. Got it. Okay, thank you.
Yep, no problem. Okay, now one of the things that our friend did on the video we looked at is he did a copy of this board over. And I don't like that. And the reason is that it doesn't work the same way for relations to other components and future editability. That's not really a word, but you know what I mean. And so what I'm going to use here is I'm going to grab the side panel and I'm going to create a pattern, a rectangular pattern. And I'm going to go in this direction. Wait, what's it doing? Well, that's objects, so direction. I'm going to pick this direction. And I'm going to say 2. And, oh wait, I'm still in metric, but I don't want millimeters. I'm going to say 1 meter. And there we go. By the way, I'm starting to realize that all the wood around here is in inches and feet, or what other people from other countries call archaic units. So I'm going to change the default for this drawing, active units, 2 inches, just to make this easier. Halfway through the design, no problem. So I'll do this because sometimes I'm working with parts and I have some parts come in that are metric and some parts come in that are an inch. And I'll just be able to switch back and forth between them. So it's easy to do. Okay, so now I've got my 2 side panels here. Now I want to create a shelf. So I'm going to first assemble a new component. I'm going to call that component shelf. It's empty for now. I'm going to activate it right away because I want to work on it. I'm going to put it into place. Now I'm going to create a sketch. And I want that sketch to be on this surface here. So there we go. And I'm going to sketch a rectangle. I'm going to come in here and I'm going to try and snap. See how I got the blue X? That means it's caught that edge. So I'm going to create this like this. And I'm going to put 0.75 for my wood. And I'm going to hit return to finish. Now my shelf is there, or my rectangle's done. I'm going to enter sketch, finish my sketch. Here's the sketch of my shelf. Next thing I want to do is extrude that. So select my profile. Here's my profile. But this time, instead of putting in a distance, I'm going to say to object. And I want to extend that to the inside of this board. Make sense? But when I go here, I'm going to get the outside of the board, and I don't want the shelf to be too long. So I'm going to left click and hold, and I get to choose between whatever surfaces are below the mouse. That make sense? Notice as I roll over it, it grays out the appropriate face.
So they're called the same thing, but you distinguish because when you're hovering over one face or the other, it becomes active with light gray.
Correct. If there were something else behind there, an edge, a construction plane, something like that, that would also appear in the menu, selection menu. So I'm going to say face, boom, there it is. And it automatically figured out that that's actually 38.62 inches. There's my shelf.
Tim, could you have also just rotated and then clicked on the plane, the surface?
I could, yes.
Okay.
Yep, I could, what do you call it, orbiting?
Yeah.
Yeah, I could orbit and then pick it as well. Okay, so there's my shelf.
Did you want that to be a component or a body?
I wanted that to be a body within shelf. It's its own. I had created a new component. And so I'm creating bodies inside the new component.
But you didn't want it to join, right?
I didn't want it to join anything else. And if you'll notice, it didn't. And the reason it didn't is because I had created it as a separate component. Before I even started, I created an empty component and activated it.
Got it.
And then I did my work inside there. So if I open the browser, I see that this part has its bodies and its own sketches. So it's independent. Okay, now I want to obviously have more than one shelf. So I'm going to grab shelf. I'm going to say create, pattern, rectangular, and I have one object already selected because I selected it before I did the pattern. I can select before or after, before I issued the pattern command. Directions. I'm going to grab this as a direction. And it wants distance. And how many? Well, let's say I want 5 shelves. And I can do distance either as an extent or with spacing. At this stage in the design, it's really convenient to do extent because I can just drag up here and see how many spaces I get.
Tim, what was the initial function that you're performing here after you chose that one shelf?
Rectangular pattern, or pattern, rectangular pattern.
Okay, thank you.
You're welcome. So if I go all the way to the top, I mean, this was shown in the video, go all the way to the top, and then you can turn off visibility on the top one because the top piece is going to look different. It's going to be a top plate. That's something you can do. Done, there's my pattern. Now I looked at this, I went back and I measured my space, and you know what? It wasn't 1 meter I wanted, it was 45 inches wide. So what am I going to do? Well, I'm going to go back, activate my bookshelf so that my timeline shows the pattern of my sides. I'm going to edit the feature, and where it says 1 meter, I'm going to put 45 inches. Inches is my default unit, so I don't have to type inches. I say okay, and now my shelves have grown to fit the space because they were defined to be from this surface to the inside surface here. If I had done a move copy, that wouldn't happen. See, I can do move copy seems to kind of break the history a little bit. Move copy is often a temporary thing. So if I do a move copy, I can come here, grab this board, oops, grab this board, and move it, and things don't happen. But if I revert position, it'll go back. Now let's say this is 12.5 inches, but I got some really big books. So I'm going to go back to side panel. I'm going to highlight it. And in that feature, instead of a length of a width of, this is in millimeters, this is 12.5 inches. Let's say I change this to 16 inches. What happens? Aha. So this piece changed. The patterned piece also changed. Oh, come on. Oh, I'm pushing the wrong buttons. Okay. The pattern piece changed to 16 inches, but my shelves didn't. Why not?
You didn't put a constraint in?
Correct. So this edge snapped to the edge, but this edge didn't. Well, I can fix that. I'm going to go back. I'm going to go to shelf. I'm going to activate the shelf and fix my boo-boo. I'm going to go to my sketch. I can go to it here, or I could get it down below in the timeline. And I'm going to edit this sketch. And what am I going to do? I'm going to come in, zoom in here nice and close so I can see what's going on. I'm going to find the constraint that works for me. The constraint that I want to use is called collinear. I'm going to grab this line and this line. I'm going to finish sketch. Bingo. So the point I'm trying to make there is that the Fusion 360 is a features-based parametric modeling system. And we haven't really gotten too far into the parameters other than the fact that we edit these parameters, dimensions, and things change and update. There's a whole nother level of parameters that we'll get into later. But because it's features-based and the history is there, it keeps history. We can go back and edit this history and make changes. And it's very useful to do a family of different things with similar features. So if you had a series of knobs, if you were defining fasteners, anything like that, you can do a whole family of them this way. But I wanted to show you the extruding to a surface rather than just specifying a length and what that means for you.
Really quite different from his approach. The amount of work that he would have had to go through to change it to 48 inches from 1 meter and to go from 12 inches to 16, he would have had many more steps in his effort.
Right. And so that's you know, my approach to modeling is I know I do iterative design. I screw up lots of times. So I do a design, I come back, I fine tune it, I come back, I fine tune it. Maybe I print out a model and I come back and edit it again. So any other questions? That's kind of the things I wanted to show today.
So just
some time, people have questions.
You would have just put the top board on, which would have been a rectangle, extruding it up 3/4 inch, and then you would put the kickboard in down below.
Yeah,
Same.
pretty much the way he did it.
Okay, got it.
Pretty much the way he did it.
Rob looks like he's got a question.
No, I was actually clapping because even though I couldn't follow a lot of it, it was too fast for me because we got the video. I can go back and rewatch, and I was having problems with my, you know, and this is what I have in the videos sometimes is what I see on the screen doesn't quite look like what Tim has on the screen. So one of the things I picked up towards the end, my origin kept disappearing. Well, I noticed that all of a sudden he hit the eyeball on origin, and maybe that's where my problem was. Maybe it wasn't on all the time.
Yeah.
So, so I'm picking up things by watching it, and I'm really enjoying the fact that you've got this recorded because, you know, he's done a great job of getting through some of this stuff. And by going back and watching, I'll be able to tell more.
There's a lot of great videos on YouTube, but they don't respond to questions.
Correct.
Good
Correct.
point. So I might not have the best answer. I might stumble for it and somebody else points it out to me, and that's great. I like that. But we were hoping this group would be something where we kind of learn together, do stuff together, learn from each other, and have an opportunity to ask questions. And as we get more complicated, there's going to be other questions that I'm going to say, let me get back to you, just like I did on why the sketch plane doesn't go perpendicular. I'll dig into that.
Actually, because this is the power of the discussion, right? Dallas said he was having that problem until he realized he wasn't on the active component when he was drawing. And so I looked, and sure enough, I was still on the top of the drawing. My gray part was, even though it said active was down below, when I clicked on the active component, as you guys pointed out, as Dallas said, when I started clicking on the planes, it did start moving.
Okay.
So I think Dallas gave me the answer to that.
One thing that might be helpful is for Windows to enlarge the cursor, the mouse cursor, or have trails enabled or something like that to see where, yeah, because I'm fortunate. I have the small laptop screen and a larger 23 separate monitor, because some of this text on your window, on your screen sharing, I can't read it on a small screen.
Sorry about that. I use a 13-inch laptop, but for CAD, I have a 32-inch TV. My wife works at Sony, so I got a great deal on a 32-inch TV that uses a monitor.
Yeah, my eyes are worth it, so I bought one.
Well, what I will do is before the next one, I'll edit the cursor. I didn't think of that.
It's a good idea.
I've done a lot of screencasts, and the screencast software I use puts a bright halo on the cursor, so it's
perfect. So, I mean, something like that, just to see where you're going, so that we can kind of follow along on our screens where some of these menu options and drop down windows are.
Tim, what was the rhythm for this going forward? Next week's was different. How?
So next week's, what I had thought is I had expected it to be more beginnerish tonight, and then every other week, like next week, we would have a shorter section with the beginners, and then a more advanced topic, and then some time for show and tell, socializing, happy hour, etc.
Did I break the rules by bringing a happy hour today?
Never.
Oh, okay, good.
I had happy hour at 4 o'clock. You know, my brother is 3 time zones to the east, and he's in Pennsylvania, and the Pennsylvania government sells liquor there, and all the stores closed. And he finally had to have, he had his daughter in Seattle mail him some of his favorite whiskey. So it arrived today. So we had to have a happy hour at 4 o'clock. I went easy, honest. Might not look like it, but I did.
Unlike Travis, who made this awesome gesture and brought my wife elastic to make face mask, and he wrapped it around an empty beer can. I was heartbroken.
I needed something cylindrical that I could wrap the cord on. It just happened to be
A fire can.
Does anybody have topics that they would like to cover in the advanced part of the session next week?
Yes. I was the one that initiated the question about bringing in inserting into Canvas.
Right?
So doing splines over an image, but when I tried to offset multiply splined objects, I got the weirdest psychedelic thing that I could think of. It's just I built it out of numerous splines, but the offset function did not work. So that would be one thing that I would like to address.
Yeah, offsetting splines is problematic because splines have a variable radius, and how it's quick and it's easy to go into a negative radius with a spline.
Could you tell those of us who don't know what a spline is?
Sure, let's just quickly do one. So I'm going to go back here, and let's create a sketch on this surface here. So there's a spline feature is, come on, spline feature is when you sketch a line with various curvature with a number of different points. And it does a smooth fit curve between them.
Okay. So like
the French curve type of thing, yeah.
Yeah, it's the computer version of a French curve.
Got it, okay.
And what happens is you can get into areas where a radius is tight, and when you offset, it can be problematic. And I haven't tried offsetting splines in Fusion 360. I'm going to give it a try right now because I'm expecting trouble. It's mathematically not an easy thing to do, and I've seen various glitches on Fusion 360. So you see this radius getting very small here, right?
Yeah.
So as we go further, oh, it actually handled that one not too bad. Gave me an error message.
I use the canvas feature a lot, and everything I read, they recommend using like the 3-point arc and not the spline for exactly what you're saying. I've had so much trouble, especially on compound angles and stuff, where you're running your spline in one plane and then you try to intersect another plane. It gets really messed up.
Yeah.
Okay, I'll give that a shot and before next week and see if I can get something that's less psychedelic. Thanks.
So the recommendation there, Mark, was using 3-point curves rather than splines because they are less prone to causing complications.
Well, you'll have to, yeah, an arc only goes one direction, right? Where a spline can go multiple directions.
Yeah.
So you'd have to make a series of 3-point arcs, and you can get them to follow just about any canvas you bring in. But I found I've been making some parts that have complex angles to them, and the spline, I could never get it to offset correctly.
Yeah. I like Conics as well. So Conics give you some flexibility that, come on.
Conics.
Why is that not sliding on me? I did something wrong here. Let's try that again. A conic is kind of mathematically a quarter of an ellipse. Not exactly, but it's an easier way to think of it. Can be elliptical, parabolic. So now here we go. Oh, and this is the rho value. And a perfect conic is 0.414.
Is that a matter of opinion on your part?
That's a mathematical perfect conic. I think maybe that's an elliptical. I'll take that back. I think 0.414 is an elliptical conic. I think that's the reality. But it depends on, you can control the angles at the end by what you're doing with lines there and specify angles. Actually, or you can at least go perpendicular. You can use a construction line if you need to, but what you do is you create a line which is tangent tangent. So you see the tangency there.
Yeah.
And then you can control, let's make another line, vertical line here. And then put, where's our dimension here? Let's escape that. And I'm going to put a dimension here and here, here and here. There we go. And now I use that to control the conic. That's getting a little bit weird, but what I'll look at for next week is importing canvases and using them, and a couple of different things surrounding that for the advanced topic. For the basic topic, I'm going to suggest that we look at sketching. Sketching is very important, and getting good at sketching is critical, and understanding how to constrain sketches. So tomorrow I will select a lesson, a video lesson. I've been looking at a couple of them that are candidates for sketching. And then that'll be the beginner topic at the beginning of the meeting next week, and then we'll transition to the Canvas subject.
And the happy hour.
And the happy hour.
Okay. I mean, you didn't get there, Tim.
I know. I was like, wait, what am I missing? It's just a given. I'm not imposing that it has to be single malt or anything, A good homebrew would be awesome too.
Yeah.
At some point, I would like to see us talk about bringing in STL files and being able to modify things we might bring from Thingiverse. That came up before. There's a lot of us that bring in files from there but want to modify them to suit other purposes, and I'd like to be able to do that in Fusion.
Yeah, okay, that's a good topic, importing parts, because you see that there's these, there's Mcmaster-Carr, and then there's also this parts for CAD, and there's a few other websites out there. GrabCAD is one, and you can go find all these great models other people have made.
But Tim, in particular, I don't know how familiar you are with Thingiverse, but that was the one that Dallas was referring to, and there are 100, 200,000 models out there for 3D printing. So we'd be importing STLs. The particular workflow that, correct me if I'm wrong, Dallas, but you were talking about bringing in STLs, right, and modifying them here? Okay.
Right.
Okay.
Yeah, that's a good challenging topic, and that's not one I've done. So I'll dig into that a little bit. I'm not familiar with Thingiverse.
I think there'd be a lot of us would be interested in doing that because many of us use Thingiverse, and also there's a number of files available on the Sketchup warehouse. I mean, hundreds of thousands of them, and we could bring those into an STL and rework them, or you can bring them in as a SketchUp file directly into Fusion, but it still comes in as a mesh.
So can you export step files from SketchUp?
I wish we could, but no, we can't.
Yeah, I don't think so.
So what file formats are possible to export from SketchUp?
You can get a DFX, you can get STL, and that's all I can recall.
I don't think, unless you have the SketchUp Pro, I don't think you can export DXF, but you can STL.
I do have the Pro version. I can open it up in my other.
Yeah.
Tim, this is kind of like the first time in the first session where you're hearing a little bit of that hunger for not having to go to Thingiverse and do things in Tinkercad and go over and use SketchUp because of the warehouse but having one tool that we can come to. So this is a really useful one, since most people on this call here happen to have 3D printers, and Thingiverse is just the classic go-to source for models that have been done by others but might not be quite for you. So Dallas's ambition of tweaking it is something that, I mean, we all have as a base desire in the advanced group.
Okay, yeah. STL files I've only ever used, I've exported to STL to send to service bureaus, because STL is not typically an exchange format, but I can see it's important. So let's dig into that one.
Great.
Great.
And then before too long, I know that we're going to want a number of us are going to want Mark or Lou or somebody to walk us through running the 3D printer straight from Fusion 360.
Yep.
And I'd rather someone who actually had the machine and has done it would do that. But Dallas, you're muted.
Yeah, you're muted, Dallas.
Actually, I've run them to my 3D printer from Fusion. It's pretty straightforward. So a couple steps can show us. And I think Mark said he does it all the time. So
yeah, that'd be great. Like I say, I'd rather have someone who does it show us rather than me try and figure it out without having a machine here. Because you learn things when you go to the machine.
Dallas, do you have something you want to say?
I'm sorry, go ahead.
Dallas?
Yes, I'm looking. I pulled up SketchUp and looked at what files I can export in. It gives me a choice of 3ds, an AutoCAD DXF and DWFG, Google Earth, an object file, an OBJ, STL, and an XSI file. Those are my choices.
Okay. So STL is the most 3D of those.
Yeah, that's the one that most of us would be using.
Yeah. Okay.
I stomped on Mark. Sorry about that, Mark. You wanted to say something?
I was just going to point out that the Fusion has a lot of settings for slicing, a lot. I've only used the basic ones, so that would be something you might want to get into advanced with. Actually, what I find easier if you're going to do advanced things is to export your STL and use Prusa Slicer. It's more intuitive, but I can definitely show you how to go straight from Fusion with the basic settings.
Okay. Good. So we got a couple of good topics coming up.
Yeah, how about going from Fusion to like a CNC router, like a Shapeoko or something, just generating G code? Is that
That's
something
really
that
easy.
is that easy?
Sam, yes.
Excellent.
Yeah, we need to cover that one as well, because a lot of interest in that. Well, thank you, everyone. Any more questions? I think I'm not sure, does this thing log us off right at 8:30 or not necessarily?
It'll stay going as long as we keep going until we end the meeting.
Oh, okay. Well, I don't have anywhere to go yet tonight except bed, so I'm
Thanks very
open.
much, Tim.
Yeah, thanks, Tim. That was great.
Yeah. Any more questions? And let's use the discussion group. Feel free to fire questions on there and answers, and don't wait for someone else to answer it if you know the answers.
Got it. Thanks very
Hey,
much.
Tim. Thank
Happy
you so
hour.
much first.
Thanks.
And then second, will you be able to post this to YouTube or another location if we want to rewatch it? Oh, to the
Yes,
website.
Travis will take care of that because I'm not exactly sure how he's going to do that.
Elizabeth, are you trying to do this yourself? Or are you trying to get your daughter at age 1 to be the expert? I don't understand. Who's this really for?
Well, it's for me because halfway through this, I always have to feed her and put her to bed. So and I come back and I see this amazing bookshelf and I think, I wonder if I could figure out how to draw that.
Got it.